This movie is about arrays and using division to test for conditions. We're going to talk about that, and we're going to talk about using the double negative to convert the arrays that are Boolean true-false into a mathematical 0-1, which will make your calculations quicker. And we're going to apply those two concepts to the aggregate function and the sum product function. So I've got a worksheet set up that's similar to the worksheet for the last movie, where I have some data that's lined up row by row instead of column by column. I have sales and I have a salesperson. And again, I've done that so I can depict what's below there, I think, a little bit more clearly rather than doing it by a column. So what is below there is some conditional tests. The first one being, is the sales greater than 300? In the first case it is, and the second case it is. The third case, obviously, it's not. The second conditional test is whether the salesperson is Dave or not. The first condition it is, then we have Ron and John, and then we have Dave again. So from those conditional tests, I've generated a Boolean result. It's either true or it's false. And with that result, I can test as to whether both conditions are true or one or the other condition is true, which is what I've done here. If you're testing for an OR situation, you use addition. Excel treats true as equal to 1 and false as equal to 0. So when I add true and true together, I'm actually adding 1 plus 1, which equals 2. So the OR condition is satisfied where one or the other is true if I have any other number other than 0. In this case, 1 plus 0 is 1, so the OR condition is satisfied. One or the other is true. And in this case, neither are true. So 0 plus 0 is 0. For the AND situation, you use multiplication. I need both of these conditions to be true. So 1 times 1 is 1, and anything times 0 is 0. So where there is a 0, both of those conditions are not true, and they're only true if I have a 1 as a result of the multiplication. So now is where the division comes in. Instead of using nested ifs to test for conditions or multiple conditions, we can use division, because when you divide the OR result by the values in the array, anytime I get a number, the value in the array that's associated with that number satisfies the conditions, where one or the other conditional test is true. The only data points where that isn't true, I get divided by 0, so I get an error message. The same thing is true with the AND situation. If I take the data points and divide the data points by the mathematical result that we have by multiplying the conditional tests together, anytime I get a value, in this case the value equals the data point, that data point satisfies the conditions. And anytime I get a divided by 0, an error message, the data point does not satisfy the conditions. So if I can figure out some way to eliminate the data points that have the error, then I've got the array that I'm after that satisfies the conditional testing. But before we do that, we're going to talk about one more concept, and that is to multiply your arrays by a double negative. So why would we do that? Well, if your array begins with the Boolean result of true and false, which Excel handles by making false 0 and true 1, we can actually do the math and convert the true false to zeros and ones, which will actually help Excel with the calculation speed. So what does that look like? When we multiply 0 times a negative, we get 0, and we do it again, we still have 0, so we haven't really accomplished much other than converting false to 0, which Excel was going to do anyway. For true, we multiply it by a negative. True is 1. We get a negative 1. We multiply that by a negative again, and we get a positive 1. So we've converted true to 1, which Excel was going to do anyway. But if we do it, it actually helps the calculation speed. So if you have a lot of array formulas, this can help with your calculation speed. So now we're going to apply those two concepts by building some aggregate functions and some sum product functions. So we're going to use the formula evaluator to step through the formulas that we have over here, beginning with the aggregate function. The aggregate function is sort of a function on steroids. There are 19 different choices that you have when you're determining what sort of calculation the aggregate function is going to perform. The function numbers 14 through 19 are programmed to handle arrays, so we're going to use 14. And then there are 8 options that you have in determining what sort of data you're going to use in the aggregate function. We're going to choose option 6, which is to ignore the error values, because we're generating error values with this division calculation that we're doing. So how does this work? To begin with, the large function will take an array and it will generate the first, second, third, what have you, fourth largest value. In this case, we're going to get the second largest value, which is 505. The only larger value than that is 579. So going to the Formulas tab in the Formula Evaluator, we're going to first evaluate the first array, which is the sales amounts. Then we're going to evaluate the array for the test as to whether the salesperson is Dave. We get our Boolean result, true and false. Then it's going to evaluate the other test as to whether the sales value is above 300. And we get our Boolean result array of trues and falses. We're going to add those two arrays together, and when we perform math on those trues and falses, they become ones and zeros. And then we're going to test that array to make sure all those values are greater than 0. And if not, we want a false. If they are, we want a true, because the first result is a 2. And if we perform any math on the array data point 306 that's in the first position, we're going to get an incorrect, invalid answer. So I'm going to convert that array to trues and falses, and when we divide our sales data points by that array, we get the exact same result as we have in the fourth block for the OR condition. And then pulling out the second highest value, it's 505. I'm going to close that, and we're going to evaluate the other aggregate formula where we're using double negatives. The first thing that's evaluated again is the sales array. Then we're going to evaluate the test for whether the salesperson is Dave. We get trues and falses, our Boolean result. We're going to multiply that by a double negative, and that allows us to convert the trues and falses to an array of ones and zeros. We're going to then evaluate the second test, whether the sales is greater than 300. We get our Boolean result of trues and falses. We multiply that times a double negative, and we convert that to ones and zeros. When we multiply those two arrays together, we get the exact same result as we have in block 3. And then when we divide the sales array by this array, we get the exact same array that we have in block 4. And since we only have one answer that fits the conditions, that's 306, I'm going to get the highest value, which we only have one value, and that is 306. So when I evaluate this one more time, we get the correct result, which is 306. For the sum product function, it doesn't allow us to automatically ignore errors. So we're going to have to get rid of the errors in a different way. We're going to embed the if-error function within the sum product function. So going to the Formula Evaluator, we have our sales, we have our first conditional test, we have our second conditional test, and now we want to convert this array, just as we did before, into a true and false array by testing as to whether these values are greater than 0, because I'm going to use that result, which is really ones and zeros, to divide the sales array by. So when I do that, I get the exact same array that we got in block 4, but now we need to get rid of the errors, which we're using the if-error function to do, and we're going to apply that if-error to the array, and if one of those data points in the array is an error, and there are 2 of them, we're going to get rid of the error value and replace it with a blank character space. When we do that, we have all the values and 2 blank character spaces, which will be ignored in the sum product function, and the sum product function adds up the array, and we get our answer of 2601. The other sum product function works exactly the same way, only we're doing a multiplication to test for an AND situation. but it's structured just like the other sum product function. So that's arrays and division. We talked about using division instead of nested if statements to test some conditions on some data points. And we also talked about using double negatives to help with the efficient calculation of the array formulas. We applied both of those concepts in an aggregate function and a sum product function.